Thank you so much for joining us tonight. It should be a really interesting event tonight, a Smolts tale, dams and tides. And we've got two great speakers, Jamie from Galloway Fisheries Trust, Jessica from University of Glasgow, giving us a bit of an insight to a rather exciting project that's been going on in the Dee River system here in southwest Scotland. Just a quick word, if I can, first of all. My first name's McNabb Laurie. My first name's McNabb. My surname's Laurie. McNabb Laurie. Working on the Galloway Glens project, a primarily lottery-funded project, but also with significant support from partners such as Drax, who are the owners of the Galloway Hydro Scheme. We're a 5-year scheme, and this is actually the second event in our winter programme. So some of you I know were at the Place Names event we held a couple of weeks ago, and next Wednesday night we've got a rather exciting event about Romans in southwest Scotland. So don't ever say that the Galloway Glens is not eclectic and covering a range of activities, because it's got a whole range of activities sorted. So yes, without further ado, I'd love to introduce our first speaker. So Jamie, if you're happy to start sharing your screen. Delighted to hand over to Jamie Ribbons from Galloway Fisheries Trust. Some of you will know Galloway Fisheries Trust. The Galloway Glens scheme has been lucky enough to work with Jamie and the team on a whole range of projects over the last couple of years. We've done interns placed with them, the rather exciting Blackwater Dee habitat restoration project as well. So the whole range of exciting things that Galloway Fisheries Trust have been working on. But tonight, talking specifically about smolt migration through the Dee. And I can see your screen there, Jamie, if you're happy to unmute.
Great, thank you very much for the introduction. Okay, for the next half hour or so, I'm going to talk about a smolt migration study that we did on the Kirkcudbrightshire Dee. This work was undertaken in 2021. Okay, so acknowledgements first of all. So the fieldwork for this project was undertaken by Galloway Fisheries Trust staff, so that was catching smolts and actually tagging them. The project design and the data analysis was undertaken by various experts from SEEN, which is part of University of Glasgow, and that includes Jess, who is the next speaker. So she was involved in the data analysis and project design for this project. And the funding for this study came from Drax, who now own and run the Galloway Hydro Scheme, Galloway Glens Landscape Partnership, which, as you know, is a lottery-funded project, which is taking part within the Dee catchment, and also some funding came from the Kirkcudbrightshire Dee District Salmon Fishery Board. So first of all, life cycle of salmon. So as I'm sure you all know, salmon spend some of their time, their early years in fresh water, then they migrate to the sea, and they return back to spawn in the river. So they go between fresh water and the marine environment. So typically around the Solway, in these rivers, they spend their first 2 years within the fresh water, growing within the burns and within the rivers, before they undergo a process called smoltification, and they become smolts. And then they want to leave the river system, and that's mainly during April and May that they'll leave the river system as smolts. And it's a particularly vulnerable life stage. So they spent 2 years in the same burns parts of the river, moving very small distances, but then they suddenly have to go through quite significant migration downstream, through the river, through any dams, waterfalls, systems like that, through it into the estuarine environment, and then out to sea. So when they're within the river system, as the picture on the left-hand side shows here, this is what typical par looks like. So this is a fish that's at least 1 year old within the river system. They're dark typically, because that's good camouflage, good colour to be able to hide in amongst stones within the riverbed. Under river banks and such like, and that's when they're in their fresh water. But when they become smolts, they go through a number of different changes, as you can see with this picture on the right hand side here. So they become silver in colour. They change colour because silver is better to be camouflaged at sea. That's why fish from the sea are typically silver. So they want to change colour. It's not the right colour when you're in the river though, so another reason why they want to leave the river as quickly as possible. They also need to go through quite a major change in their physiology to be able to survive at sea. So any fish that goes between freshwater and the sea, there's a big impact as they go through that process, because basically once they're into the salt water, the water is drawn out of their bodies, so they need to be able to drink water and excrete salt via their gills and through concentrated salt in their urine. and that's called osmoregulation. So it's a big process for a fish to be able to go from basically fresh water back into the sea and back. So significant change that they need to go through. They also grow longer. So you can see in this picture here, they become more elongated, particularly the tail end, as they become more adapted, ready for their long migration within the sea, and the fins darken as well. So once it becomes smolts, like this one in the hand in the picture here, this is then ready for sea, and they need to get out of the system as quickly as possible, migrate out. Okay, so back to the Dee now. So anyone that isn't local, the Kirkcudbrightshire Dee is located in Dumfries and Galloway. The very top of the catchment actually lies just in South Ayrshire. The catchment is just over 1,000 square kilometres, so it's a large river catchment. It's 70 kilometres long from the very top down into the estuarine habitat. And in 1929, the Galloway Waters Power Act came into place, and that was what was required for the construction of the Galloway Hydro Scheme. The Galloway Hydro Scheme was 5 power stations, 8 dams, all the various infrastructure and pipework which was required to go with that. And it was the first integrated scheme that was built in the UK. It was built between 1932 and 1936, so it was built over 4 years. It had a cost of £3 million, and at its busiest, it employed over 1,500 workers who were involved in the construction of it. And it's pretty much stayed the same. The only change to the present Galloway Hydro Scheme was that in 1985, an additional power station was built at the very top of the scheme. So it is a heavily modified catchment. The Galloway Hydro Scheme has obviously modified the river over those 4 years since the early 1930s. As with most on-river systems like this, its power generation is timed to meet peak demand. So the way that it moves water between the various different dams and within the river system is very much timed to be able to hit sort of early evening, sort of key times people coming back from work. And that's the advantage, obviously, of a hydro scheme. Its power output is about 109 megawatts output when it's generating. And the infrastructure is pretty much exactly the same and operational 90 years later after it was built. So it's quite a feat of engineering when this was built. A bit more description about how the sort of system lies across the catchment. So at the very top of the system, the Loch Doon is linked to the Galloway Hydro Scheme. So that's at the very top of the headwaters, just up there of the River Doon, which is an Ayrshire River, and that's used as a seasonal storage reservoir. You have a power station up here, Drumjohn. That was the last one that was built in 1985, and there's a water transfer that can occur between Loch Doon and the very top of the Dee catchment. As you move down the system, down to here, you then have the Ken and Duke dams, and they hold water back for the Ken Doon power station. As you work further down the system, you have Kirkcudbrightshire Dam and Earlston Dam, with Kirkcudbrightshire power stations and Earlston power stations just downstream of those. You then come to Loch Ken, which is roughly in the middle of the entire system. This is about a 14-kilometre long loch, which Glenloch, a barrage at the very bottom of it, can allow an increase or decrease of height of roughly 2 meters. So again, water can be held back there. So when the barrage is open, it can act more like a river. And there's quite significant flow through it, but that can be held back. And then to the west of Loch Ken, you have the Blackwater Dee entering into Loch Ken. And near the top of that, Classing Shores Dam was constructed, and that's the other seasonal storage reservoir. And a condensation flow continues to go down the main Blackwater Dee, but the pipework takes water to the east through Glen Lee Power Station, and that discharges it back in just above Loch Ken. Then right down at the bottom of the system, the main power generation comes from Tongland Power Station with its associated dam at Tongland. That's just near Kirkcudbright, and that's just upstream of the upper tidal limit So it obviously influences the river system quite significantly. And two key aspects when we're thinking about the smolt research we did is that the wild fish, there is no fish passes at catching shores or Ken Dune dams. So no migratory fish are able to access those parts of the catchment, which is about 25% of the catchment. Okay, so there is a Vacky fish counter. So the picture at the top left-hand side here is the fish pass at Tongland. It's about 200 meters long. And there is a Vacky fish counter that GFT run on behalf of Drax, and that allows any fish entering the river system to be counted. So it counts, the Vacky fish counters are quite sophisticated counters. They can tell whether it's a salmon or sea trout, gives you an indication of size, and it also takes a photo of every fish so you can see the condition of the fish. So it provides a lot of very detailed information. And when the Vacky first went in 2007, it was counting for the first 10 years roughly between 500 and about 1,000 salmon coming in. We then had a couple of years where the fish counter had some issues with regard to effective working, and in the last couple of years we have very low counts, just under 100 in 2021, and this year it's a bit over 100. There's still been fish coming in recently, but that follows very much with the national trend, where 21 and 22 have been very low numbers of returning fish coming back to the river systems. And this is why we're so interested, particularly to push on with this smolt research and try and understand and find out about. We've already highlighted that smolts is a particularly vulnerable life stage where high numbers could potentially be lost coming out from the river. So we're very keen to understand more about this sensitive life stage. Okay, so all parties agreed about undertaking a smolt research project, but one of the problems is obviously comes in is being able to catch smolts. Smolts have quite a small window of when they're going to migrate, so there's roughly a month to 6 weeks that they want to leave the river systems. And one of the downsides, obviously, if you have a low salmon population, is being able to effectively catch enough smolts. So what was chosen was to run fyke nets in the Coombe Burn and the Polharrow Burn. So these were both identified through electrofishing surveys as having adequate, decent numbers of par the year before, which indicated that we would expect a decent smolt run. And fyke nets are basically designed to catch downstream moving fish. So you can see with these two pictures that we've got these white panels on the side, and those net panels push fish into the green net. Within the green net, you may be just be able to see from these pictures, you have a number of smaller nets, so that once the fish go into these sort of funnel nets, they can only really move one direction, keep moving downstream and into the plastic catch boxes at the very end. So these can be very effective in the right place at catching downstream migrating smolts and do them no harm as we catch them as well. So just to help understand about the location of what we had to do before the project started. So the Polharrow and the Coombe Burn were picked as suitable locations for the fyke net. So Polharrow is upstream of Earlston, so that the good thing with that meant that any smolts tagged and released at that point, we could follow them through Earlston Reservoir and through the dam power station set up there. Coombe Burn was a bit further downstream, but we're still in a useful location for the upper river. We then have receivers. So with acoustic tags, they give off a signal, and you have these static receivers that you locate at different locations up and down the river. They can pick up, I believe, about 100 to 200 meters away if they have a clear sight of any acoustic tagged smolt going past. And these are located at different locations to try and pick up smolts as they move down through the system. This is obviously the first year we did this, so these are fairly well spread out across whole catchment to try and understand if there's any sort of key areas of concern at all. But in particular, we're interested in Earlston Reservoir and the setup up at the top there. We're interested in Loch Ken. Historically, there's been a lot of concerns about pike predation possibly in Loch Ken, and historically, the District Salmon Fishery Board did used to net and the power companies used to actually do quite a lot of pike netting, a lot of ken because of the concerns of predation. We were interested in the barrage at the bottom of Loch Ken, then down at Tongland and up into the top of the estuary as well. These are all locations where you might find increased smolt predation or losses. So that was an idea of where everything was located roughly. So we started to trap smolts in early April in 2021, and we were really encouraged to catch 50 smolts within 12 days. As soon as we hit the 50, we took the nets out just to allow the rest of the smolts just to be able to leave the system unhindered. One of the conditions that we've been given by Glasgow University was that not only did we have to obviously catch 50 smolts, so they also had to be big enough and heavy enough to be able to take the tag loading. And we were given a minimum size of 150 millimeters, which on some of the rivers, you would get significant numbers of smolts under that size. What we were particularly happy to find was the size of these smolts that were coming out of these systems were very, very large. So we caught no smolts that were not large enough to be able to be tagged. You can see from the numbers in this table that Polharrow particularly gave us a lot of smolts. We had 47 smolts from there at the same time that we got 3 from the Coombe. And as I said, as soon as we hit 50, we removed the nets. The mean lengths were up to about 170 millimeters, which is very, very large for smolts and significantly larger than smolts that we found in other rivers in Dumfries and Galloway. This is probably partly due to the lower densities in some of these places that there's particularly good growth rates up there. But yes, very encouraging that we were able to catch smolts quickly and that we were able to tag them. So just a brief summary of what we started to find. So 39 of the tagged smolts took part properly in the experiment. So as with any smolt tagging project, some are lost at the very start, and that can be from tag failure, from losing the tag, possibly from being predated, or death through the process of tagging, or that they simply halted their migration because of the capturing them and going through the process of the tagging, that they've just delayed their migration stage. So we only include in analysis the actual smolts that properly start and act in a natural way, acting down through the river. So of the tagged smolts at Polharrow, upstream of Earlston, all of them got through the lock-up at Earlston. We had just over 80% survival of between the receivers just upstream of the dam and the power station compared to just downstream of it. The next key area of interest was Loch Ken, and within Loch Ken we had an 82.8% survival of the smolts that were picked up entering Loch Ken and leaving Loch Ken. The ones that, difference between what entered and left. Between receivers 10 and 13, which was the lower riverine section, which is again about the same length as Loch Ken, so about 13-14 kilometers long, we lost no smolts within that section of the riverine habitat, 100% survival. Receivers 15 and 16 went in slightly late for various reasons, so some of the early running smolts weren't picked up through those, but of the ones that we were able to track properly through that section, we had 87.5% survival going through Tongland Power Station, past the dam and the power station. Receiver 14, which is sort of hidden under the end of that blue arrow there, that was on basically that would record any smolts that went down the fish pass and didn't go actually through the power station, and that didn't pick up any smolts going through the fish pass. And then between receivers 15 and 16, which is a lower river and upper estuary, which is downstream of Tongland, again we had 100% survival of the smolts that we tracked between 15 and 16. So the overall survival that we had was nearly 60% of the smolts from when they were the ones that we tagged from the top, that coming down through the overall system. So Survival rates for this experiment was higher than similar studies on other impounded rivers. So other impounded rivers as in other hydro rivers. We had a higher survival rate than we expected, which was good. We had a riverine migration success, which was particularly high. So we have riverine habitat between Earlston and the top of Loch Ken. And then we have from the bottom of Loch Ken down to just above Tongland, quite a significant section of the river. We only lost a single smolt within all of that section, which was surprising and encouraging. The loch migration success was also very high compared to other studies of loch migration. 100% got through Earlston and 83% got through Loch Ken. And Loch Ken, remember, is significant length at 14 kilometres. And then we had variable survival at the different impoundments. So at the Glenlocker Barrage, 100%, no losses were picked up there at all. Down at Tongland Dam, which is particularly of interest because no smolt can leave the entire Dee system unless it goes through Tongland. We had 88% survival. And at Earlston Dam, we had 81% survival. And the estuarine migration success was very high as well, 100%. So the mean time to migrate out of the Dee system was about 30 days. So about a month they took to go out. And the mean speed that they took when they were migrating through the riverine section was 29 meters per second. 0.29 meters per second. And about half the speed when they were going through the loch habitats. So just in summary, so again, just to highlight, a higher than expected survival rate at 60% nearly for a river with large impoundments found in 2021. So that's very comparable, if even higher, I think, than some rivers and some studies that they found without impoundments. But that was just in 1 year, remember. So that was 2021. Maybe that was a particularly good year, or is that an average year? Migration success through Earlston and Loch Ken was very high for lochs. So when you compare it to other research undertaken but by other people, and Glasgow University were particularly surprised and interested about how high the migration success was through these lochs. So if you remember the previous slide, we just highlighted that the migration speed was about half the speed when they're going through lochs. So normally, when fish are slowed down, they're more likely to be lost through things like predation. And in the riverine habitat, the fish did move downstream at all times, but some of the receivers within Loch Ken and Earlston did show the fish moving upstream at different times and basically having to search around because they're trying to work out which is the best direction to go, which is quite typical for research for lochs, particularly for some smolts. A similar high success rate in the early estuarine environment, which again is quite different from some other studies in other areas, which suggest that can be a particular focus for a loss of smolts at that stage. A reduced migration success at Tongland Dam and Earlston Dam. Now, this could be because of the way that the study was undertaken. It's not possible to tell whether this loss was through a direct mortality through the turbines or because it's a delayed migration, there was an increase of predation. So if the smolts, which they are, traveling through the turbines, and the turbines are not on all the time, obviously, because the hydro scheme targets a sort of optimal key times to provide power and energy, then potentially the smolts are held back at these key times, and that could increase the predation. So it's nothing to do with actual turbine damage, but it's just through the process of being held back. At the impoundments at Earlston and Tongland, so Glasgow University did some more analysis of the data since, and what they basically found is 94% successful passage when the turbines are operating. So these smolts are going through the turbines, and they're successfully going through the turbines. The overall migration mortality was nearly 1% per kilometre for the Polharrow fish, and about just over 1.5% for the coombe burn smolts. But as we said at the start, we only tagged 3 fish from the coombe. So because of the larger sample size, the data that's more relevant will be the Polharrow. So losing about 1% per kilometre. And that, so the distance that the Polharrow fish went was about 40 kilometres. Was the distance that they had to migrate. So quite a significant migration distance that they were having to do. And it's proposed to repeat and expand out this study in 2023. All the same partners are keen to be involved and to take it on to the next step. So the proposed research for this coming spring, which is being worked up at the moment, is to expand quite heavily out the number of receivers, so up to 36 receivers will be put out. And this will allow a far more detailed look at some of these key locations that we picked up around the dams and such like, to try and understand exactly where the smolts might have been lost, what power generation, what the hydro does that helps the smolts exactly. We're also keen to go further up the system. So one encouraging thing, even though we have a low number of fish in the river at the moment, is the Pol Maddy burn, which is right at the very top, sort of one of the uppermost points that fish could access. In the last 2 or 3 years, we've started to find salmon finally returning to that. Pol Maddy is a significant burn which was suffering from acidification, but with improving air quality, forestry restructuring, etc., the water quality does seem to have improved in there, and we have a salmon population coming back and expanding into there. So we think that's a suitable location to try to tag smolts, and that would just pull it up above Cysfad as well. So a huge amount of information could come from this expanded rollout in 2023. And Drax are keen to understand how they could vary turbine operation during the smolt run, which, if you remember, is only a few weeks of the year, to see how they could potentially change their operations to speed up and increase the survival of smolts through this. So this is why we are so keen on this. So this is research with a real purpose, exactly what the Dee needs of trying to look at how we can increase the survival of smolts coming through. Thank you.
Brilliant. Thank you. Thank you so much, Jamie. That was really, really good to get a snapshot of the work you've done the last year. I was hoping to use my chairman's prerogative to ask some questions, but we've had some questions in. I should probably defer to the audience for that. Do these smolts ever use fish passes at Ulston and Tongland as a downstream route? Have you ever picked up on that?
So at Tongland, where it's a particularly large fish pass there and a potential draw water, but it's quite far away from the main turbine, there was a receiver put on there, and none of the smolts that were picked up going down there went through that choice. They did go with the main flow, as sort of expected. Ulston and Cysfad, we wouldn't have been able to tell that with the study that we did last year, but with the expanded rollout in 2023. That would be possible. But again, as I showed with the research from Glasgow University, by far the majority of successful movement went through when the turbines were operating.
Cool. A great question from Lynn here saying, I know there's plenty of pike near Threave Castle, so the smolts must get through this area quite quickly, seeing as you didn't lose any. Was that a surprise, Jamie, in terms of predation in the lower areas?
Yes, it was a surprise to get such high survival within the riverine sections, because there are a lot of different fish species, particularly pike and large perch and stuff in there. One of the things that a lot of research has shown is that larger smolts will survive better and can evade predation better, particularly for some of the fish predators. But yes, it was encouraging that the numbers got through at that stage.
Mark asked here, what was the age of the smolts coming through the system, S2s or S3s?
So we checked a few, and there was a mix of S2s and S3s from the Polharrow. It was mainly the larger Polharrow ones we checked, and that is untypical for Dumfries and Galloway, because we think that about 70% of the smolts from our previous work are S2s. We get a few S1s, down about 90 millimeters, but very unusual to get S3s. But these were mostly S3s of the big ones that we picked up.
Cool. A question here from Will Marshall here. Do the smolt tags last till the salmon return?
No. So the idea the smaller the tag, the better. So as part of this study, because the fish were only going to be in the river between 1 to 2 months was what we had estimated, then we went to some very small, called V5 tags, which are only about 5 millimeters wide, just over 10 millimeters long. So they're the very, very small tags, and that means that they don't last very long. So what was felt was that it was more appropriate to go to small tags to minimize sort of impact, but that means no, you can't pick them up coming back.
Brilliant. And quite a complex question here, probably, Jamie, but just in headline points, was the weather last year in your mind slightly? Was it a good year for smolts, do you think, or is that why you're interested in doing it for another year?
Yeah, so this is what was interesting, because some smolt studies suggested that 2021 produced some higher survival. I think this is some from Urban Island were higher than typical, but we did have quite a dry year here in 2021. But the big difference, obviously, on the Kirkcudbrightshire Dee is that it is a heavily modified, and that the flows can be varied quite a lot by the power generation. So that's what we're interested as well, of trying to see just how exactly the fish react, whether they're reacting to the air pressure and the rainfall, or whether actually they've been more modified by the changes of flow that Drax undertakes. Because if it's a second one, then it's really interesting, because we can potentially manipulate work with Drax and others to how we can try and get the fish quickly out of the system.
I suppose it's a perfect example of how you have to be candid with anything for 1 year, isn't it? It's always a risk. You want to get the multiple years into it to try and compare the two. Brilliant. There's a couple more questions coming in there, but I'm mindful of time. So if you're happy, Jessica, to start sharing your screen, I'll just make the audience white hot with excitement at your arrival. So we've got delighted to have Dr. Jessica Roger now talking from University of Glasgow, the Atlantic Salmon Trust Research Fellow at the University of Glasgow, working on the Atlantic Salmon Trust's West Coast Tracking Project. And I'm delighted, Jessica, if you're going to give us a wee snapshot of marine migration of salmon, particularly the work Central Scotland and the Solway. The floor is yours.
Excellent. Yep. Hello, I'm Jess, as McNav has just said, and I'm going to focus on the marine migration now of salmon smolts after Jamie's given a great overview of the project looking at freshwater migration in the Dee. So I just want to start with a little bit about the migration of salmon smolts in general before moving on to looking at the marine migration of salmon smolts, and then finishing off with some results from projects that happened in 2021. So as Jamie has already shown this diagram already, we know that Atlantic salmon juveniles undertake a risky long distance migration from their natal river to rich feeding grounds at sea. So the stage in the life cycle that we're going to focus on, as Jamie said, is the smolts. They're undergoing a massive physiological, behavioural and morphological transformation that allows them to survive in saltwater. And the most prominent change that we can see is their morphological changes, where they become elongated and silver. So in the spring, the smolts begin their migration out of the river and towards their feeding grounds in the sea, covering thousands of kilometres. So salmon smolts, when they hit the sea, they're heading towards the Voring Plateau Escarpment in the Norwegian Sea, which is up here, where they will feed and grow before they return to our rivers to spawn. They'll also go out to Greenland and the seas around Greenland itself, and they will feed and grow there as well. So they've got a couple of different places that they'll go to feed. So as I said, the long distance migration is risky for salmon smolts, and there's many costs and benefits associated with it. And I just want to spend a little bit of time discussing that. So what are some of the costs of migration or a long distance migration? First, there's the large energetic cost associated with, there's a large energetic cost associated with migration itself, as well as the migration being time consuming. So it takes a long time to cover those thousands of kilometres. And it's going to require a lot of energy. And there's also the energetic costs associated with the physiological and morphological changes that salmon smolts make during the smolting process. By migrating out to sea to feed and grow larger, salmon smolts are delaying the reproduction reproductive maturation, which means smolts are taking a risk by migrating out to sea because they may actually never return to our rivers to spawn. Another cost of the migration is navigational error. So smolts may simply get lost on their way to the Norwegian Sea. And if they migrate in the wrong direction, they may never reach their feeding grounds. And the third cost, I've kind of lumped together quite a few things here, but they're all novel things that salmon smolts will encounter. So salmon smolts will encounter novel prey items, as well as predators. And we know in the marine environment, there's an elevated risk of predation. They will also encounter novel parasites and diseases. And all of these things salmon smolts will have to overcome if they're going to reach their feeding grounds in the Norwegian Sea. There's quite a lot of costs for migration for salmon. However, salmon still migrate out to sea, so the benefits must outweigh the costs. And one major benefit to migrating to sea is that they have access to improved feeding resources. So we know that the marine environment has much higher productivity than in freshwater, and that means that when the salmon smolts are in the sea, they have access to a lot more food resources. And that means that they can increase their mass much quicker, and they can grow to much greater sizes than if they stayed in freshwater. And that larger size benefits both males and females. So we know that males achieve a greater breeding success if they're larger because they can outcompete the smaller males. And that for females, they would have an increased fecundity. So they're producing more higher quality eggs in a larger female. So currently the benefits of migration outweigh the costs, but with climate change, the distribution of prey resources are shifting, as well as current patterns and other geological or geographical features are changing. And that could mean that there could be a shift where the benefits of migration no longer outweigh the costs. So I've just mentioned climate change as a pressure which could impact or alter the pathways or success of salmon smolts during their marine migration. And some other factors include offshore developments such as wind farms and aquaculture, illegal offshore fisheries, as well as predation. So recently the Scottish Government sold a large area of seabed for offshore wind farms to be developed. So could these wind farms be affecting or benefiting salmon smolts during their migration? For aquaculture, do the migration routes of salmon smolts, do they intersect aquaculture pens? Does the distribution of infectious stages of sea lice intersect the pathways of salmon smolts? Do illegal fisheries capture large numbers of salmon? Is there a high level of predation, and is it natural, or is it exacerbated by anthropogenic pressures? Or is the increase in offshore developments increasing the number of predators? So are predators congregating around these structures? And you'll notice I'm posing a lot of questions here, and that's simply because we actually know relatively little about the early phase of the marine migration of salmon smolts and how these factors could be impacting that migration. So what we do know is salmon smolts from the UK and Ireland are migrating out towards the slope current at the continental shelf to the west of the Outer Hebrides. And then they're following the North Atlantic current, which is roughly where the red arrow on the map is, to the Voring Plateau Escarpment in the Norwegian Sea, which we know is where their feeding grounds are. And we know this by trawling surveys, which were carried out by projects such as CSLR and SALSI. So here I've got a map of where the SALSI project caught salmon smolts in their pelagic trawls. And you can see the green dots on the map are at the slope current at the continental shelf, and then the red dots are out at the Norwegian Sea. So we know that's where they're heading to, but what we don't know is what the migration pathways salmon smolts use to reach the slope current at the continental shelf. So how do they get, or what routes do they take to migrate from their natal river to that slope current? What navigational mechanisms do salmon smolts use when they are migrating through the marine waters? So salmon smolts can either use passive swimming, where they use simple current following behaviour, or they can use active swimming, where they actively navigate and swim to the destination that they're going to. So in 2020, Ainsley et al. Published the smolt dispersal model, and that basically predicted the direction of migration for salmon smolts from the west coast of Scotland during the early phase of their marine migration. And this model found that salmon smolts from different regions would migrate in different directions, but also that current following behaviour alone would not be enough for salmon smolts to reach the slope current at the continental shelf. So it's probably that active navigation and swimming is required for the smolts to get to the slope current. So there's more modelling studies that are ongoing at the moment, looking at the navigational mechanisms and the cues that salmon smolts might use during their migration. And the third kind of strand of questions that we know relatively little about, and I've already touched upon, is that we don't do the migration pathways of smolts intersect these anthropogenic pressures, and how do these pressures affect the migration pathways? So until recently, most of the information we have about the migration of salmon smolts comes from trawling, as I've just mentioned, but they also use coded tags and floy tags, which are great, but they rely on the salmon being captured again. So over the last decade or so, acoustic telemetry has been used to track salmon during their migration, and the advances in the technology means that we are able to track salmon further out to sea. So Jamie's already touched on this, but I just want to quickly recap on how acoustic telemetry works. It can be used to answer questions relating to behaviour, physiology, interactions with habitats and other animals, as well as looking at movement patterns. So as aquatic animals are inherently difficult to observe, as we know in the wild, we can use acoustic telemetry to track the movements of that animal. So for it to work, we need two components. We have the transmitter or tag, which is either attached or surgically inserted into the animal. And that tag has been programmed to emit a coded ping at a set frequency. So the coded ping relates to an identifier which is unique for each individual used in the study. And the tag emits the coded ping at a set interval throughout the study, so it could be like a 25-second delay between pings. And these pings are then picked up by a series of receivers or listening stations, which are deployed throughout the study area. And these receivers detect the pings as the fish that's tagged swims past the receiver, and the receiver then records the time, date, and the individual identifier of that fish. And that information is then stored on the receiver. So once the study is complete, we can go along, retrieve all the receivers and download the data, and then we can start making inferences about the migration routes taken by the animals being tracked. So just to look at some more capture methods, Jamie's already mentioned the fyke nets, but we can also use other methods. This is not an exhaustive list, but you could use seine netting, which you can see here, and you can use a rotary screw trap, which is in the river. And then this picture here is a kind of overview of how we acoustically tag the salmon smolts. We do it surgically. We have two tagging teams here, and these are the tags that we can use. We're obviously not using these great big giant tags in our smolts because they're far too big, but we do something like this size down at the smaller end of the scale. So here are some examples of the receivers being deployed in freshwater. In the top left, we basically have a chain link with a bit of rebar soldered on, and the receiver is attached to the rebar, so that stays in the river throughout the study. Whereas in the marine environment, it's a lot more rough and it's also a lot deeper, so we have to use a different type of receiver, and that's the receiver you can see in all the other pictures with the three orange buoys. And these receivers have an automatic release mechanism, so when we communicate with the receiver, we can activate that mechanism that releases the canister. And the canister is full of rope, so the receiver basically floats to the surface with the buoys, and we're able to pull up the receiver once it's at the surface, all the rope and the weight that's attached. So in 2021, there was multiple telemetry projects co-occurring in the area of sea shown on the map here, and that allowed us to start answering some of the questions about the early phase of the marine migration of salmon smolts. So the maps I'm about to show you The stars are tagging sites, so that's where we caught the salmon smolts, or the projects caught the salmon smolts, and the dots are acoustic receivers that have been deployed, with each dot being an individual receiver. So the projects operating in 2021 included the Compass project, which was a 3-year project tracking salmon and sea trout from the east coast of Northern Ireland and Ireland. And in 2021, they tagged around 85 salmon smolts, as well as deploying an acoustic array of receivers between Larne and Portpatrick. So if I mention array, basically it's just a line of multiple acoustic receivers. Another project that was happening in this area was the Sea Marsh project. That's an Interreg funded project, and they were tagging salmon in Scotland, Northern Ireland and Ireland. In 2021, Sea Marsh were tagged around 512 salmon smolts across 6 rivers, as well as tagging a few sea trout. And the main arrays that they deployed were around the Isle of Cumbrae to the west of Arran, as well as their main array between Malin Head and Islay. What Sea Marsh also did was they deployed a wave glider out at the continental shelf to the west of the Hebrides, and that wave glider had an acoustic receiver attached to it, so it would be able to detect any salmon smolts that were migrating past the continental shelf or through the continental shelf. The next project is the West Coast Tracking Project. It's a 3-year project and has a partnership between Atlantic Salmon Trust, Fisheries Management Scotland and Marine Scotland, with the support of the University of Glasgow. And the project aims to examine the early phase of the ocean migration of salmon smolts from the west coast of Scotland. In 2021, we tagged 924 salmon smolts across 8 rivers. And deployed multiple marine arrays. So there was the array between Skye and Uist. We covered all the gaps between the islands of the Outer Hebrides, an array of the east coast of Lewis, as well as the west coast of Sutherland, as well as some receivers around Mull. And finally, some other projects that are happening in the area include the Nith Smolt Tracking Project, the Derwent Tracking Project, the Marine Institute and AFBI both tagged some additional smolts as part of their own projects. And there was also projects that weren't tracking salmon smolts, but they had deployed receivers in this area of sea, which meant that we could get opportunistic detections of our salmon smolts tagged. And they included projects such as the MEFS MPA project and the St Moses project. And all of these projects are using the same technology, all working on 69 kilohertz frequency, which meant that we could all share data between all the projects that are happening in this area. As Jamie mentioned, for the Dee project, they used quite a small tag, which operates on 180 kilohertz frequency, which meant that those tags couldn't be detected by the marine receivers shown here. But the reasoning for using the smaller tag and the 180 kilohertz frequency is because it's much better for answering freshwater questions, which was the focus of the Dee study. So as you can see, there's a lot of receivers deployed and fish tagged in 2021. There was over 2,000 salmon smolts tagged across all the projects and over 380 receivers deployed. But today I just want to focus on some of the findings from the more southerly Scottish rivers, which include the Endrick and Greif, which were part of the Sea Monitor project, and the salmon here were tagged and the data analysed by my colleagues at SEAN, and the Bladnich and Nith, which were part of the West Coast Tracking Project, and the Croic, which was part of the Nith Smolt Tracking Project. So if we look more closely at this area, we have our 5 tagging sites, which are the stars, as well as our arrays. So just to recap, we've got the Compass array at the south, the Sea Monitor array at the north of the Irish Sea, an array to the west of Arran, and 2 arrays around Cumbrae. So we start to look at the migratory routes of salmon smolts from these rivers, and we start with the River Bladnich, which is part of the West Coast Tracking Project. On the map, you'll see I've added some arrows. So these are really a simplified illustration of the migratory pathways taken by the salmon smolts. Using acoustic telemetry, we know that the smolts got from A to B, but we don't know the pathway they took in between. So I've added arrows to give an indication of the general direction salmon smolts were migrating in. So of the 53 salmon smolts that exited the River Bladnoch, 12 were detected on the compass array, and it took these salmon smolts an average of 10 days swimming at an average migratory speed of 12.8 kilometres per day to reach the compass array. And then 10 smolts were detected on the sea monitor array, leaving the Irish Sea. And these smolts took around 3 days to get from the compass array to the sea monitor array, and you can see that their migratory speed, or average migratory speed, has increased quite massively to 38.9 kilometres a day. Moving on to the Nith, which is part of the West Coast Tracking Project as well, and the Croic, which is part of the Nith Smolt Tracking Project and is a tributary of the River Nith. So because these two have the same river mouth of the Nith, I've clumped them together. So 90 smolts left the River Nith, and 20 of those were detected on the compass array, taking around 12 days to migrate from the river mouth to the compass array. And then 12 smolts were detected on the sea monitor array between Malin and Islay, and it took these smolts around 3.5 days to migrate from compass to sea monitor at an average migratory speed of 36.7 kilometres a day, so very similar to the Bladnoch fish. Moving on to the Gryfe, which drains into the Clyde estuary and is one of the rivers from the Sea Monitor project. 93 smolts were detected leaving the river, and 80 smolts from the Gryfe were detected going past the arrays at the Isle of Cumbrae. Interestingly, the majority of the smolts were migrating down the west side of Cumbrae, with only one smolt detected on the east side. And it took these smolts an average of 5 days to migrate from the river mouth to Cumbrae, basically, at an average speed of around 13.7 kilometres a day. So once smolts left the island of Cumbrae, they could migrate either west around Arran or down in the waters to the east of Arran. And the Sea Monitor project detected 4 smolts going down the west of Arran. And it's presumed the remaining smolts that were detected on other arrays went down the east side of Arran. So it took smolts 4 days, it took 4 smolts, an average of 4 days. Oh my goodness, 4 smolts, an average of 8 days to migrate from Cumbrae to the west side of Arran. And now the smolts could either migrate north or south once they exited the Firth of Clyde. And we'd have expected them all to migrate north because that is the way that they need to go. However, 6 smolts from the Gryfe were detected migrating south and were detected on the compass array. And it took them about 18 days to get from Cumbrae to the compass array. And of the 6 smolts detected on the compass array, 2 then turned around and were detected migrating north as they were detected on the Sea Monitor array. And a further 27 smolts from the Cumbrae array were detected. 27 smolts from the Gryfe were detected on the Sea Monitor array. So there was 29 in total. And finally, for the River Endrick, which also drains into the Clyde estuary and part of the Sea Monitor project, out of the 50 smolts that were detected leaving the river, 38 were detected on the arrays around Cumbrae. And similar to the Gryfe, there was a preference with the majority of them migrating down the west side of the island, with only one smolt detected migrating down the east side of Cumbrae. And they also took an average, they took about an average of 5 days to migrate from the river mouth to here. So unlike the Gryfe smolts, all the Endrick smolts must have migrated down the east side of Arran, as we did not detect, the Sea Monitor project did not detect them migrating down the west side of the island. And again, Endrick smolts were also detected migrating south, with 4 detected on the compass array. And it took these smolts an average of 13.5 days to migrate from the Cumbrae to the compass array. And from the 4 smolts detected on the compass array, only 1 then was subsequently detected on the sea monitor array migrating north. And in addition to this, there was also another 9 smolts detected on the sea monitor array from the Drax. So we had 10 smolts detected there. And it took the smolts around 18 days to get from the Cumbria array to the sea monitor array. So the multiple telemetry studies in 2021 have started to shed some light on the migration pathways taken by salmon smolts. I've obviously just focused on one area, but these studies are showing that there's quite a bit of variation in the migration of salmon smolts through the Irish Sea. There's differences in the migration route taken. As we've seen for the Greif and the Endrick, even though individuals originate from the same river, they're taking different migratory routes once they hit the sea, going different sides of islands, some going south and some going directly north, as well as the migration speed varying from about 4.3 kilometres a day to 38.9 kilometres a day. So thank you, and I just want to thank everyone who has allowed me to present on their behalf today, this Sea Monitor project and the West Coast Tracking Project and the Smolt Tracking Project. So thank you.
Cool, thank you. Thank you so much. Thank you so much, Jessica, for giving us an overview there. I think it's startling to see 2 presentations work so well together, because we've got Jamie focusing on the within Galloway, and then you plugging it into a more global position. I'd love to put a couple of questions to both of you. Just to jump on one that I think was probably related to Jamie's presentation about Jamie, can I jump back to yours? Any guess how many smolts might make the journey in the current climate each season? So you were talking about the 50 that you caught. Have you any idea? And it's an impossible question, I suppose, but what proportion that is, or a guesstimate or a figure that you would use?
No, we don't have an estimation of the number of smolts coming out. We can sort of try and back calculate it, but we'd like to start to look more at this. Some of the latest fishing surveys we're looking at is to try and get an idea of what some of the key locations. The problem is that a lot of the production is within the main river, within the Dee, and it's very difficult to get into there to actually get a detailed density of fish in there. So I'm going to have to sidestep that question.
Thanks. So, sorry, I wanted to come back to you just in case I missed it, but moving on to sort of Jess's section a bit more, or maybe actually both of you, we've talked a bit about things eating smolts and things eating salmon, but what is the main food source the smolts consume as smolts and then as salmon? I don't know, Jess, can you give us a sort of snapshot from your point of view about?
They'll eat like small zooplankton and stuff as quite small food when they first hit the estuaries and the marine waters, but as they grow they'll start to eat sand eels. Is like their main food source. Jamie, do you know of any additional?
Have you got a river angle on that, Jamie, in terms of what?
So they won't feed a huge amount during the actual smolt migration. When they're within the river system, they're eating mainly aquatic invertebrates and mayflies, stoneflies, and smolts will go through an increased feeding point just before they smolt. So they will try and feed up and sort of build up body mass just before they smolt in the actual spring. But the juveniles within the river are eating aquatic invertebrates.
That's an amazing variety throughout the life cycle, but isn't it? Just looking from your presentation, Jess, seems to be quite a high loss in the early sea travel stages. Numbers leaving rivers and numbers hitting the arrays. Were you surprised by that, or have you got anything in your mind as what's going on?
Yeah, so we have to take the numbers that were detected. We can't really translate that to loss as such, because the detection range of the acoustic receivers is never 100% in the marine environment. So we will have missed smolts that have migrated through completely undetected, or they might have gone a different way. For example, the Bladnogsmith smolts might have decided to go south around Ireland. We don't know, because we don't have any arrays down there. So we can't really answer that just yet.
But there's nothing jumping out as reasons for loss in your mind at that stage.
Predation in that area. We know that there's predation. Like, that is just a fact of life. It's natural. It occurs.
Sorry.
Yeah.
I was going to say, Jess, do you want to say anything about predator tags? Because there is specialised ways you can look at predation, isn't there?
Yeah. So we can use two different types of tags. We can use predator tags, which basically have an enzyme coat on the tag. So when it's the smolt who's been tagged is eaten by a predator, the enzyme coat dissolves and it changes the code. So the identifier changes, and that basically tells us that that fish has been eaten. That works really well in freshwater. I don't know of anyone that's done it within the marine environment. But in the marine environment, something else you can do is get depth and temperature tags. So we know that smolts should be swimming in the top 1-2 meters of water, so at the surface in the sea. And if we have depth and temperature tags, that can tell us if we suddenly find a smolt 50 meters down, then maybe it's not a smolt anymore and it's in a predator, or if it's been eaten by a mammal and the temperature suddenly increases, then you know that it might have been eaten.
Yeah. You can make assumptions on that basis. And
yeah.
There's a question here which should probably be a whole symposium in its own right, but about navigation. Is there anything you can say, Jess, about what do we know? How do you understand these fish navigate?
So there's still so many questions to be answered, but what we think at the moment is they're using currents for some of the time. They're using the currents. Once they get out to the continental shelf, they're using that strong North Atlantic current to migrate north. So they are following the current to a certain extent. To get there, there's a lot of research happening at the moment. Some people are looking at salinity gradients. So to see, because there's a lot of fresh water coming in and the salinity gradient shifts with the current, I believe. So they're using that as a cue potentially. Cool. But this is what all the modelling work's working on right now. Cool. Trying to work it out.
Is there nothing you'd add, Jamie, apart from the complexity of the
I just agree with Jess. I mean, sort of smell from individual rivers as well, isn't there? There's a belief that when they're coming back, the way that they can home back. But there is some evidence that basically fish often go into the wrong rivers, just into the lower sections, and then for a few days, and then come back out and explore into the right rivers.
Cool. Yeah. Can I abuse my position as chairman, just ask a very quick question of my own right, which is, what did the data show anything about time of day? Is there any sort of headline point that what time of day maybe if I can come to you, Jamie, first, actually, in terms of in the river, does there anything come out about what time of day?
So it's well known that smolts will migrate at night. So that's one of the key things we're really interested with regard to if the smolts can be drawn through these turbines, and we can increase the sort of speed. Is try and get this timing right, because they're unlikely, unless there's a high flood, then on the whole smolts will just migrate on that. It's all about predator evasion. So if they have a high flood, they'll go with that. That's a quick way to get out the river system. Otherwise, they will swim out. They'll wait until it's dark. So this is where it may be interesting to being able to manipulate the flows, because if the turbines are open but it's daylight and then it's closing, and then the smolts want to move at that point. So it's always been well known that smolts, on the whole, will migrate at night.
Oh, interesting. So it changes from a weeks of interest to actually you can refine it to particular periods that are a focus then, can't you? There's an excellent question here about the high tidal flows in the estuaries. And do you find the fish pause in backwaters when the flow is against the direction of travel? I suppose really, Jess, is that a point about timings and speeds that they're in the ground, really?
So a bit of work that's recently come out from a colleague at SEAM is that they looked at estuarine movement and the ebb and flow of the tides, and they found basically the smolts were moving backwards and forwards with the tide until a certain point, and then they would migrate out. So there is a certain hanging around, I don't know if it's hanging around, but they are moving backwards and forwards with the tide at the estuarine bit.
We're fighting to stand still, probably, rather than hanging around. Is that
Yeah, I think they're just moving back. Wait until the timing's right, I think, and then they're off. Maybe adjusting to the seawater as well, because they have just come from fresh water into slightly salty water, and then they're full strength seawater. So they do need a bit of time to adjust to that as well.
Cool. The question coming from Will Marshall here, which I think actually probably answered, which was about, do we assume numbers detected are just those that pass the detectors, or is the missing smolts mortality? And I think you mentioned that there, you don't have 100% confidence that the detectors catch them all, so have to put an asterisk beside it, a bit of both really on that one. Looking at the question on everyone's lips at the moment about climate change and impact of rising water temperatures, Can I come to you, Jess, about elevated seawater temperatures? And do you have any emerging thoughts about impacts or what this?
Well, it's going to change the prey distribution. So the prey that salmon smolts are hunting for as they enter the sea environment is going to change. It could be that larger prey moves in and the salmon smolts simply can't eat that prey. It's all about the right size prey and the smolts hitting the water at the right time. And if those two match up, we're all good. But if they don't match up, which is what climate change might cause differences in, then the smolts are going to struggle a little bit more to find food.
I suppose the question ends here with the comment of whether that would be beneficial or detrimental, which is an interesting angle to consider, isn't it? Because you've got to be open to both, I suppose.
Yes, you do.
In situation. The question about the costs here of a project like this, acoustic telemetry must be pretty expensive. As budgets come under pressure, is there a danger of project curtailment? So I think to an extent, that's sort of been answered by seeing how the project on the Dee plugs into the bigger picture, and say it is a small part of the bigger picture. But I suppose it's probably the reasons to try and spread the information that's been learned is to try and justify future rounds. Probably, yeah. So Jessica is probably part of it.
And that is the beauty of all these projects happening at the same time. Individually, no one could. Well, maybe someone could, but it's unlikely someone could afford to pay for such a big scale project. But by working with so many different partners and so many different projects, it means that we're getting a lot more bang for the buck, if you know what I mean. Like you're able to cover a much larger area. But yes, acoustic telemetry is quite expensive.
Brilliant. These are just brilliant questions. Thank you so much, all. I'm so fortunate to be able to be putting these to the panel. Jamie, if I could come to you, is it possible that warmer winters and lower snowfall has contributed to problems with sufficient snowmelt in April and May to help smolts out to sea? So is that something we used to experience, as there used to be a spike of snowmelt that was helpful that doesn't happen anymore?
So this is far more significant in some of the larger rivers up north, rivers like Kirkcudbrightshire Dee, Aberdeenshire Dee, which very much picks up issues with snow melt and stuff. These rivers in southwest Scotland are far more spate rivers, but they do drop very, very fast in some of these drought springs that we've had, and it's a major concern to us about just how dry some of these springs have been in the last few years. We think there's quite a significant loss of smolts within the rivers. We were surprised by the high survival rate that we found in the tagging on the Dee. And again, there may be this opportunity to manipulate flows and actually try and bypass some of these problems that we have in other rivers, particularly other rivers where we have a large pike population and high numbers of predators. That when you get these low flows, the smolts just will not leave the river systems. They just stop and they wait for these higher flows, and they can delay by up to months of some of their migration time. So the longer they're stuck in the river, the more likely our predators will identify that they're there and cause problems. So dry springs are a real disaster.
Yeah. So it's unintended impacts of these things. How a great question here. If I could come to you, Jamie. Older fishermen used to say smolts go downstream backwards. I don't know if you have any view on this particular.
Yep. No, it's pretty much true. You can see the way that smolts sit within the river systems, and they're quite passive. So it's always frustrating to think that a smolt, if it really made an effort, could swim from top of one of these rivers out to the bottom in a few days if it wanted to. But when we get these dry spells, they just sit and they wait, and they do get largely sort of washed out the river as they drop down. So
cool. There was a report last year that found Irish and Scottish smolts identified by their DNA on the inshore northern Norwegian coastal current close to Bergen. This may mean that smolts from this way do make their way across the North Sea to the coast of Norway, where they can be impacted by sea lice from salmon farms. Is there an angle? Do you find I suppose coming to you, Jess, really, is that the international angle to this is probably very interesting. Have you got some international partners involved on that front and try and track the whole cycle? We
don't on the projects that I've presented here, but there are other projects that are getting underway. So there is it's not confirmed or anything, but there's a project trying to get off the ground that's looking at putting an array between Bergen and Shetland, so that'd be right across the Northern Sea, and that would then start to tie in fish from Norway, Scotland, UK, Southern Europe, everywhere basically, going through that area of sea. So there is work underway to do an even bigger scale.
It's probably beyond the reach even of the Galloway Glen scheme for something like that, Jessica, I think, absolutely. Do you have any plans to tag other species like sea trout or river lamprey? I can come to you, Jamie. I don't know. Is this something you've tried with other species, or do you have an ambition with other species?
No, so years ago, we did a salmon tracking project on the Cree and on the Bladnoch. And that was far larger tags that were put into the stomachs of fish as they were coming back in because they don't feed in fresh water. And some really interesting thing came out from those results. We also tagged some sparling years ago. These are far larger tags. And again, some really interesting ideas about sort of migration routes and stuff. At the moment, the sort of key area that we've been keen on is obviously to look at what was happening within the Dee because of the concerns, and we're very keen to do research where we can have a management output. So that's why we're so keen to try and do it on the Dee, because there is an opportunity to try and change things here, and the river needs it. So not at the moment. We would love to, but as you sort of highlighted, it is expensive. And it would need to be a sort of focused project with a clear outcome, I think.
There's a just brilliant dinner party question here that could go on for hours, just very headline. In evolutionary terms, have fish always migrated? I don't know if you have anything that comes to mind, either Jessica or Jamie. Have you ever found yourself thinking about this?
So salmon, so during the Ice Age, salmon are out in the refuges at sea, and then they migrated into the river. So since then, they have migrated. But there is evidence in some populations where salmon have either lost the ability to migrate or they don't migrate anymore. So there's a population in Finland in one of the lakes. They stay at a small size and they live in the lake the entire year. They never migrate out to sea. And there's a couple of populations, I believe, in Canada and North America.
Wow.
But it's unusual.
Yeah.
But it could be that if the costs of migration start to outweigh the benefits, more salmon will remain within the river, which means you might start to see some populations cropping up where they don't migrate out to sea, or very few migrate out to sea because it's no longer beneficial. The cost is too great. They're going to die before they can spawn, which is, for a salmon, that's all they want to do. Feed, spawn. That's it.
You have species like trout that go through a whole range, salmon cruta, that they can be resident within river systems and never go to sea. They can become sea trout. You can have all the males staying within the river because they're quite happy to be small, and the females migrate to sea to increase egg production. On the loose, we've come across large female sea trout spawning very small male brown trout. So there's so many different options. And then even within river systems, nearly every fish species will do some level of migration, even if it's only short distance, to go to key feeding or spawning areas. So as a species, fish migrate at different distances, different species, for lots of different reasons. So as Jess showed in her slides, it's all about sort of cost benefit analysis. Is it worth it? And some will always keep trying it, just to experiment and see whether things have changed or not.
Cool. That's absolutely brilliant answers, both. Thank you so much. I'm conscious of time, and I'll keep it absolutely on point. But just this last question here: why do you think Clyde smolts swim much more slowly than the Bladnoch and Nith smolts? Do they have to arrive at the head point by a certain time, and do they have further to travel? Have you picked up on a faster or slower populations, Jessica? Or
there is difference between populations, and I think it's to do with how fast the currents are in that area or how complex the area is to migrate through. So the Clyde smolts, the Edric and Greif, they've got to go through the estuary and then the Firth of Clyde before they hit the Irish Sea, whereas the Bladnoch and Nith smolts, once they're in the Irish Sea, they're just going north. So they don't have a hugely complex environment to go through, but also the currents in that area are really strong, so it will be pulling the smolts through at a much quicker speed. Cool.
Is anything you'd add there, Jamie, in terms of difference of population performance, or is it a relative?
How have we got fast smolts?
That's what we put it. In Galloway, it happens. Cool. I think I'm conscious of time. It's been absolutely brilliant. Thanks so much for questions. Any outstanding questions, we can pop them either directly to Jamie or Jessica after today. Before you go, I need to say, massive thank you, first of all, to Jamie and Jessica for the presentations tonight. Absolutely brilliant to give an insight in first of all, how something in Galloway has come together, and then how that plugs into the bigger picture. And I think it's a really absolute testament to particularly Jamie spearheading the local work and sport. We've got Drax from the owners of the Galloway Hydro Scheme, SEPA involvement. I'm delighted that Galloway Glens using National Lottery Heritage Fund, he's been able to put money in as well. So a real partnership project, and it's lovely to see that it's not being done in isolation, that it's actually plugging into the bigger picture. So thank you both very much. We'll send out an email tomorrow to all participants with a very short, I promise, feedback form, asking for a couple of feedback points on how you found the event tonight. But I can't let you go without mentioning next Wednesday evening is the event Romans in Galloway. So we've got Dr. Andrew Tibbs, some of you know, and Andrew Nicholson, who's the council's archaeologist, who I'm sure many of you will know, talking about Romans in Galloway. Why did they not stay here as long as they stayed other places? And should we take that personally? So next Wednesday night, but I'll put a link to book in for that event in the email that I send tomorrow. And I think it leaves me just to call time on proceedings. Thank you. Thank you all very much for joining us tonight. Massive thanks again to presenters, and keep an eye on the Galloway Glens channels for future events. Brilliant.